So in these lessons, let's discuss about the flow cache. So to understand the concept, like I just basically showing some example, there's a router, so that's configured for exporting NETFLOW. So whenever there's a PC here, so this trying to access the one of the server in this side. So in that way, we will just look at the basic sort of transaction, like when a client accessing a server. So what is the sort of flow export or flow cache look like? So flow cache is something like a space in the memory where I try to keep a track of the certain field detail when a traffic going through the device. So in the previously we define a flow. Flow is a unidirectional traffic, in that way, in this particular example, when a client device trying to reach the server, that is a unidirectional traffic. So router will try to keep a record of a certain key information. So what are the key fields? In this particular example, I have given you the sort of a flow record, what information being collected. You can see certain information we highlighted as a key information. So those are match keyword, those IP toss byte, toss value, type of service value, protocol, source destination IP, and source destination port, and input interface, and the flow direction. So in this example, there are 8 fields. So these are basically categorizing as the key field. And then you have something called non-key field. So those are additional information we are collecting. So those are normally specified in the collect statement in the flow record definition. So we will go into this configuration in the next module, but just to explain the concept, I just show you that's what basically our flow record. These are the parameters we are being basically capturing. So then all these interfaces, gig 0/0, 0/1, and the tunnel interface, which is IPsec tunnel establishing to a data center just in this particular setup. So we including those monitor, which will basically calling for the record value R2 we defined earlier. So now how you can basically monitor this, show flow monitor command. You can basically show flow monitor, specify the flow monitor, and cache keyword. So that will give the flow cache information. So then while you are doing this particular, while I'm just accessing this particular server from this client, I just ran this multiple time. That's how I just collect the information. I just filtered to IP address 75 and 101. So 101 is my DNS server, 100.75 is my server, the client trying to access. In that way, you will not get every flow information, so it is easy for you to visualize. So I just get in the CSV format, in the format CSV option. In that way, I can easily open this in Excel rather than working out one by one. So now let's go into the this communication little bit granular, so bit by bit, understanding how the flow cache work for UDP, TCP, and ICMP. Those are the 3 sort of IP level protocol that most of the traffic is belonging to. So now if you are accessing any device in the internet, the first sort of transaction is you have to basically resolve name to IP address. That's what we're using DNS for. So normally any communication you will see this example, while I'm doing this particular testing, I have captured the Ethernet traffic of this particular wired PC. In that way you can compare what is the packet capture look like versus the flow cache. In that way you can see there are DNS query and DNS response messages. So whenever this happening, if you basically look at the flow cache, you will see related to this particular DNS query, there will be a flow created. Why? Because the flow is identified by this unique field, source IP, destination IP, source port, destination port, input interface, and the flow direction. So you can see here this direction, they will be creating a flow. This is the information keeping in the memory of the router. There's a flow of traffic is going in. So when the response coming from the DNS server to the client, So this is the response detail, and you can see now this time source IP will be the server IP address, destination will be the client IP address. So that is basically not unique. It is basically different source and different destination. So that translate into another traffic flow. So that way, that will be a unique traffic flow. The source port will be 53, destination port will be the 53419, and it is coming into the tunnel interface from the router point of view. And again, input direction traffic, and IP protocol is 17, which is UDP. So now in here, if you look at the information we are being collected as per the record, so we have to collect the TCP flag because the UDP traffic, there are no TCP flags here. It will be asking to collect the output interface. That's router know which interface traffic is going out, and the byte count and the packet count. And then there's something called time first, time seen first, and time seen last. This will be help to identify how long the traffic flow is active. If it is a traffic flow is inactive, you can basically export that traffic flow, and so in that way we will be using this field. So in that way, this is not the all the flow based on my flow record definition. This is the flow it is being collected. So sometime in today's NETFLOW version 9, you can specify the application tag as well. In that way, if you want to differentiate application tag as a key field, you can use that as well. So now this is how UDP sort of flow export work. Let's look at the TCP next. So now in our communication point of view, normally once we resolve the DNS, once we find out the IP address of our server which we want to reach out, so then we will basically establishing a TCP, three-way handshake. So you can see here, like this is the packet capture, whole packet capture. I have given you the packet capture. In that way you can go through your own. To make it simplify, I just simply export the packet based on these particular two IP. In that way you will not have all these particular raw packet data. In that way, that's why packet numbering goes one onward. But in the the same sort of capture, but I exported flow conversation between these two endpoints. In that way it is simple. So now three-way handshake happening, and then these are TCP packet, and then you can see I try to access the HTTP port number 8787, which is the SolarWinds NETFLOW traffic analyzer access port. I just basically use, that's why the traffic goes 8787 port number. Just to make it simple, I just access HTTP. In that way this traffic is not encrypted. If you are interested to go into this packet capture and find out the detail, you should be able to find out what username password I use. That's I will leave up to you, because this is we are focusing on the flow cache, so I'm not trying to go through the every individual packet detail, but you get the idea. So the TCP traffic is here. So now if you want to look at the that particular flow cache, so again this is the sort of packet coming from my client IP address, and then going to the NETFLOW traffic analyzer 75 port number this. So these are the different unique fields compared to the previous flows. Previously we look at the UDP flow, and this will be establishing a new flow entry in our flow cache. So in here, because it's a TCP traffic, it will have the flags detail. So initially if it is a SYN packet, this should basically reflecting what's correlated to the TCP SYN kind of hex value. I will explain later why this is not that little bit later. So now the byte and packet count, and again time seen first and time seen last. So IP protocol this time 6, which is TCP. So now when the SYN packet goes to the server responding with SYN ACK. So in that way, this time source will be the server IP address 100.75, and destination will be the 129.101. So this is different to the previous flow. It's creating another flow in the cache. So that is basically reporting here the flow cache. So now again the next packet comes, it will be acknowledgement. So now if you look at carefully, if you look at this key information field, that is same as the first seen packet. In that way, source IP address, source port number, destination IP, destination port, protocol, input direction, and the type of service value and IP protocol all same. So if it is the same, it will not creating a new flow. Why? Because the same flow previously has been seen. But only thing is the TCP flag is different. So in that way, the TCP flag will be amended. They will be adding this additional information. That's why this particular hex value, you will see sometime different values because different information is there. And then the byte count, they will be incrementing because this is the same flow. They're incrementing the bytes and the packet count as well. And the times last value will be updated because it is seen by recently. So like that, depending on this particular flow, you will see these flow detail will be updating. So if you look at the frame number 4 to 14, you will see the same sort of flow number 3 and 4. If you look at the port numbers, everything is same. In that way, this traffic flow 3 and 4 will be get updated based on the detail of this particular packet. And then, like if you look at further in this particular packet capture, you will see there are, 15 to, if you go, then there will be different TCP port number. That means the client trying to establish multiple TCP session using different port number. So if it's a different port number, so it will be previously we had a 3 and 4. Now this time packet number 15 will be port 52632. So that will be a different flow in the cache. So return traffic coming, again it should be a different flow. Why? Because source and destination are different this time. And then you will see another time 52632. This will be another sort of this is a return traffic come to here, but again it is even though the same port number but different source destination. In that way, that will be a different flow. So like that, this will be flows will be creating in the cache. That's what happening with the TCP. So now so in this particular example, just to show you what happened in the ICMP as well, I just ping from this particular machine to this particular server, just to show you what information being recorded in the flow cache. So now what I did was actually I just ping from this PC to this server, but you can see the server did not responded. Maybe the firewall blocked it, like that way I didn't get the response. But to find out in the flow cache what information is there, this is the same packet capture, like same packet capture. If you filter by ICMP, you will find these 4 packets. So now what happened in here, like again, source IP, destination IP, the source port, destination port. Normally in ICMP, there are no port numbers like that. In that way, I will explain a little bit later then what this port number is. But input interface, flow direction, other detail will be there. The IP protocol will be 1, which is ICMP. So you can see the packet count will be 4. That's because it's sending 4 packets. Whenever you're doing ICMP, it will be by default sending 5. But initially it didn't go through. That's why it is 4 packets sent. That's why the packet count here is 4. So now I said, what is this destination port? In ICMP, actually, ICMP has a different type of packet. Mainly we use echo and echo reply, ping and ping responses. So they have something called type value. So that's why here type value 8, you can see it's echo request, and type value 0 is echo response or echo reply. So not only the type value, some of these have a code value as well. In that way, for example, this destination unreachable, there are various reasons for destination unreachable. Depending on this code value, other side can understand what was the exact reason for why destination did not respond. So now ICMP echo and echo reply perspective, always this code value is 0. So that way these echo responses, code value will be 0. So now then if you want to understand then what is this value port, destination port 2048 translate into, you need to basically work it out what is the hex value. So this is the decimal value 2048. If you convert into hex, it will be 800. So that means 0800. So this is the sort of coding bit how it goes. The first two one, this particular thing reflecting the type value. This is reflecting the code value. So now code value 0, we said always echo request response code value 0. So 08 translate into echo request. In that way, what we are telling here is this is an echo request message. So like that, in ICMP, code and type value will be encoded into the destination port number. In that way, just remember, if you are interested to find this detail, you pay attention, you will get this detail, and then if a collector understand this, they can interpret this information coming in the destination port. So now that's what we looked at, like we looked at UDP, we looked at TCP, and we looked at ICMP as well. In that way, whatever the traffic you looked at in a given network, you should see one of these type in the flow cache. So then what happened in the flow cache, once you router will not forever keeping the flow cache information. So this is the example flow cache detail. Router will be periodically sending it to a third party device or something we call flow collector. In that way, you need to know when the flow is being exported. In that way, there are few different methods flow exporter will use. So one option is if it is a end of a flow, like if it is TCP reset or TCP finish message seen, that means we are terminating that flow, then immediately flow can be exported. That's the one option you can use. If it's a TCP based traffic, we can do that. The other method is actually if it's a flow is inactive, that means last seen value or time last seen sometime, if it is not changing, like if a difference between time first seen and time last seen, if it is a 15 second, that means a flow has been 15 second. But if there are no traffic seen further after the first scene for 15 seconds, that means that flow is idle. So you can declare that flow is inactive. In that way, if it is inactive flow, so it is waiting for 15 seconds and then exporting immediately after that. So sometime it is a Cisco also by default, it's a 15 second. In that way, you don't want to configure specifically. It's a best practice value as well. So now, if it's active flows, that means sometime like FTP transaction, it can go longer time, 15-20 minutes, that's possible. So now one option is you can wait for ending of that particular TCP session. That means you have to wait for 20 minutes to export that flow. So sometimes it is not idle waiting that long because you want to get some accurate reflection of the traffic going through the device. So that way it is a good idea to reduce this active timeout to 60 seconds. That's the recommended value. Sometimes some of the Cisco devices is still default value is 30 minutes because at the time of NetFlow introduction, it was a service provider kind of use cases. They were not worry about real-time traffic monitoring. So that's why the default setting is 30 minutes. But definitely you should change the active timeout 60 seconds. In that way, every 1 minute, we exporting traffic for active traffic flows. The other option is any of these devices, the memory is not unlimited. So you will allocate certain memory. In that way, if a flow cache getting filled, then that is one option. When the flow cache basically full, that also option to exporting. So that way the bottom line is we periodically exporting to a collector. That's what happening in this scenario. So now this is the information you need to know about flow cache. But before we basically move into some other lessons, let's talk about certain detail when related to the NetFlow. So one thing is actually what we call flow stitching. You need to know what is flow stitching mean. So in a NetFlow conversation, we said all this particular record we are exporting is a unidirectional flow. That means these are sometimes for client and server communication, this will have two different flow. But in your point of view, to understand, you like bidirectional conversation. So in that way, if you want to understand this in a bidirectional conversation, your collector need to do stitching. So this is called flow stitching, where you basically using this unidirectional flows convert into bidirectional communication. So in that way, sometimes there's one reason is basically to understand the flow better. The other thing is sometimes your return traffic come via different router. So your incoming and outgoing path are two different devices going through. So that way return path will not seen by this particular flow exporter. So even that particular scenario as well, your collector can correlate these. This is the response to the previous packet. Even though it is not coming from the same exporter, collector can take this kind of decision. In that way, if you have multiple flow collectors, sometime you may not stitch the traffic between multiple collectors, keep that in mind. But if you have most of the organization, normally we will be exporting traffic into one flow collector. So that way that collector can stitch the packet. So now in the IP fix point of view, there's a RFC as well, talking about bidirectional flow export. You can read RFC 5103 if you are interested about that. The other, so in this particular example, this is showing some of these particular traffic all related. This is the same port number, request response, and this is basically same port numbers. So those are part of the same bidirectional traffic. So there are 4 bidirectional flows in this particular flow export. That's what I'm trying to explaining here. The other information, something called flow deduplication. So again, it is important to understand sometime in your network, multiple devices can export the data as a flow exporter. So in this example, this switch also supporting NETFLOW and it can also exporting the data. Previously, we look at how this router creating this flow cache. Whenever the switch creating the flow cache, switch will creating switch specific. That means switch input interface will be 1011, output interface could be 1014, depend on the direction of the traffic. So like that, but this traffic will be going to the same both devices. So whenever you exporting this detail to the flow collector understand, even though it is coming from 2 different exporter, this is the same traffic. So in that way, they can do the deduplication. In that way, it will, it is always your collector should support deduplication. Otherwise, unnecessarily resource will be wasted and your bandwidth, your measurement will be not accurate because you are doubling up depending on the how many exporters sending this detail. That's another reason actually why we always configure NETFLOW in one direction. So that way, normally best practice is configuring it for all the interfaces in input direction. In that way, you will not basically miss the traffic. You will not basically double counting as well if it is coming from one collector. So keep in mind, so this is the sort of basic flow cache related information I would like to discuss in this particular lesson. So now what we'll go to understand the different flow collectors in the next lesson.